So now in this lecture, we shall learn that how we can apply the dead loads and live loads. So first of all, we can press Ctrl and W option on a keyboard and left click on extrude frame, untick on the extrude frames option, and we can left click on apply. And if required, if we want to remove these blue lines also, we can just click on the horizon option here, and then it shall be a simple empty screen. We can right click and left click on set grid system visibility also to see a clear 3D model of the complete footover bridge. Now, that is first thing. Second thing that we do need to do is that we do need to apply the, we can say, loading on the footover bridge. So there are like multiple options. Either we can model the shell and then we can apply the area loading, or what we can do is that we can apply the uniformly distributed load on all of these members also. So the easiest approach is that we can just left click on story 1, apply and close, and then we can go to the define section properties and slab sections. In here we can left click on, we can say add new property, type we can select it as slab only, and modeling type shall be membrane. So in here we can just select we can say a passive membrane here, that is just to transfer the load. So in here we can select the grade 300. Frankly, it doesn't matter much. So thickness we can take it as 1 mm just to ensure that it is modeled as a membrane structure here. So left click on OK, and then again left click on OK. So we can go to the draw floor and wall and quick draw floor and wall option here. So in here we can select draw object. Instead of using grids, we can select here as points. So we can model the slabs like this. We can again go to the draw floor and wall and quick draw floor and wall. So instead of the property type here, we can select it here as passive, and draw object using grid. Instead of that, we can select here as points. So we can draw a rectangle like this, and the ETAP shall automatically model the membrane here. The same shall be the system here also, and here also. So we can select all of these membranes that we have modeled. Press Ctrl and R option on a keyboard. Select DX here as 2 and number here as 9, and left click on apply. So here we can see that all the whole membrane is modeled over the complete length of the footover bridge. So either we can make it as a deck or we can make it as a membrane also. So again we can go to the plan here. Again left click on story 1 and apply, close, press Ctrl and W option on the keyboard and switch off the beams. Left click on apply and close. So we can again select all the membranes here. We can go to the assign shell loads and uniform. In here we already have dead load and live load. So under the case of dead load, we can apply 100 kg per meter square, or we can say 1 kN per meter square, considering the weight of the weight of the wooden decks that shall be installed on the top of that. Instead of 1, let us say we can assume it as 2 kN per meter square, and that too depends on the thickness of the timber deck that we shall be installing on the top. So on the conservative side, we can apply 2 kN per meter square. Left click on apply. And then again, if we're talking about the live load, so again we can select all the membranes here, and we can apply the live loading of 5 kN per meter square. So left click on close. Open the 3D view here. We can press Ctrl W option again. Set to default view option. Untick horizon and left click on apply. Close, display, undeformed shape. So now we have applied the loading also of the dead load and live load on this particular structure. So after that, we can go to the load patterns again, and we can check the seismic load also that has been copied from the earlier model. So we can left click on modify lateral loads here. So in here we know that we have to apply plus minus 0.1 eccentricity along the horizontal plan. And in addition to that, the top story, it should be up to the top, and the bottom story, it shall be from the base. And if we're talking about the site subsoil class, let us assume that it is class C. Probability factor Kp, that can be taken as 1 considering it is a normal regular structure. Hazard factor Z, performance factor SP has been taken as 0.77 and ductility factor has been taken as 2 considering the we can say a steel ordinary moment resisting frame. After that, either we can calculate time period as per the code, or what we can do is that we can enter the KT value here. So we know that KT value as per the code AS1170, it is 0.11 for steel structures. So this is the formula for, that is clause 6.2.3, which refers that 1.25 kT h into the power 0.75 shall be the time period for the ultimate limit state. In here, kT shall be 0.11 for moment resisting steel frames. And for eccentrically braced, ours is not an eccentrically braced. So we have to consider the 0.11 as the kT value. So we can enter just kT value 0.11. Let the software calculate the time period. So we can left click on OK. And similarly for the ELY also, we can select all of these options. Centricity here, it can be taken as 0.1. Top story shall be story 2 and from the bottom story shall be base only. We can keep all the parameters same considering the steel moment resisting frame and site subsoil class assuming it as C. And in here we can again refer or enter the program value KT as 0.11. So we can left click on OK. And after that, we can enter the wind load cases also. So we do have to consider the wind load along X, that is a frictional drag force along the length of the footwall bridge. And we can left click on type, we do need to enter here as wind. And auto lateral load, we can keep it as none. Although the software do allows us to calculate as per the AS1170. But the thing is that all of these calculations are valid if we're talking about the simple regular concrete buildings. And whenever we are talking about the open steel frame structures, in that case, what we have to do is that we have to calculate all of these values manually, and on the basis of the cross-sectional, we can say size and ratios, we have to apply the uniformly distributed load on all of these structural steel frames. So we can left click on none and left click on modify load. Similarly, we can enter WLY also here. And then we can, select the auto lateral load as none. So we can left click on OK again. We can save this model. So now we have applied the dead load, live load, and earthquake loads also. So if we're talking about the wind load, what we have to do is that we have to calculate that manually and then apply on this particular frame structure to help us calculate the strength. Now, before we proceed further, we just need to have, some basic checks that whether the modeling that we have done is correct or not. So we have already applied a dead load, live load. The supporting conditions are also defined, and we have also defined the dead loads, live load, earthquake loads. So without wind loads cases and without wind load combination, we can just check the structure first with whether the modeling that we have done is correct or not. So we can run the analysis here. So this is the displacement diagram under the dead load, and here we can see that at the center point, the displacement is coming only 3.5 mm, and that is like a very less displacement. So we can go to the display and deform shape also, as we are already imported the model from the earlier reference. So we do have already combinations defined. So we can check the displacement vertically under the gravity load combination. So here we can see that at the center, the displacement is approximately 8 mm under the span of 20 meters. So that is no doubt a very less value. So we can left click on start animation here to see how the foot bridge behave under the action of dead load and live load. So here we can see that how it is displacement vertically under the action of dead loads and live loads. So the second thing that we can check here is that we can go to the display and deform shape again. And in here we can, go to the mode shape here and check the fundamental mode of this particular model. So here we can see the fundamental time period that has been calculated by the software is approximately 0.565. So we can left click on start animation here And in here you can see that how the photorepeat is like displacing literally under the model uh, first mode. So after that, if you want to see the second mode here, so here you can see that how the curve has increased. So earlier there was just a single curve. Now under the second mode shape, we do have double curves. And under the next third mode combination, if you will see, the number of curves shall increase. So that is how, the model analysis or dynamic analysis can also be checked for the foot-over bridges. So after that, what we do need to check here is that we can go to the display, show tables here. And after that, we can go to the load pattern definitions, load patterns again, and load pattern definition auto seismic AS1170. So we can left click on OK here. So in here, we can see that the time period that is used is approximately, we can say 0.231, and the coefficient of the earthquake force that is used is 0.09, and the weight is the seismic weight was approximately 228 kilonewton, and which when multiplied with this coefficient gives us the base shear value along the x and y axis. So that is how we can check the values of the earthquake forces that have been applied. And so that's it. So in the next lecture, we should learn how we can calculate and apply the wind loads.